Hello, everyone. We will begin today's webinar in 2 minutes. Thank you for joining us today. As a reminder, today's webinar will be recorded and will be available to all registrants. Thanks again, everyone. And good morning, everyone. Thank you for joining us today. I am Don Burke with the Environmental Stewardship Initiative, and I will be your moderator for this webinar. I want to welcome you to today's webinar on health, safety, and disposal of new power sources. Today's event will cover the health, safety, and disposal of new power sources for newer technology, including lithium-ion batteries, and as a collaboration with the ESI Energy Management Series and the ESI Hazardous Materials Roundtable Series. Also assisting with this webinar is Scott Pfister, our ESI program consultant and lead for the ESI Energy Management Series, and Caleb Gimperlin, one of our 3 NC State interns that's joining us this summer. Our other 2, Tim Havens and Bethany Suarez, are also part in the helping with the background production today. Now, we would be remiss if we didn't thank the Waste Reduction Partners and the Land of Sky Regional Council for hosting the training on GoToWebinar. They have been wonderful partners for us, and we have shifted so much of our outreach and training lately to an online format. Terry Albrecht, Section Chief of WRP, has been a wonderful partner with these virtual ESI events. Feel free to check out the ESI events webpage, www.ncesi.org, for both upcoming events and past events, which include the webinar materials. Now, just a few housekeeping items before we dig into today's topic. If you have audio issues and are using the audio through your computer, you can switch to your telephone. Just go to the audio tab in the webinar controls box and click phone. A phone number and code will then be shown for you to use in order to access the webinar. The call-in information is also in your webinar invite email. And again, we are recording today's session. The link for the recording and materials will be posted to the ESI events webpage for everyone to access. And again, you'll be hearing me say this a few times, www.ncesi.org. Now, to prevent feedback and unintended background noise, all attendees are muted. However, we want you to ask questions and share verbally. So in order to facilitate that, we will ask you to raise your hand when you want to speak. Now be sure to mute yourself only through the GoToWebinar software using the little microphone button at the top of the control bar. It will be red when muted and green when live. If you don't necessarily want to speak, but you still have a question or comment, we encourage you to submit those through the questions box at any time. We will share these questions and comments as applicable, and after the presentations, the remaining time will be dedicated to your questions. Now, for those of you who are not familiar with our program, the Environmental Stewardship Initiative, or ESI, is a voluntary assistance and recognition program. It's been part of the North Carolina Department of Environmental Quality since 2002 and is administered by the Division of Environmental Assistance and Customer Service, DEECS. We are partially funded by an EPA pollution prevention grant and promote environmental management systems to assist organizations in their efforts to continually improve their environmental footprints. We also encourage and facilitate networking and training events that allow for peer sharing between our members on a wide range of environmental topics. If you are not yet a member and would like more information, please email Angela Barger, our ESI manager, or myself. Our contact information is on the screen, bottom left corner. We would be happy to share more information with you and answer any questions that you might have. There is no cost to join, and all we ask is an annual report on the progress made toward your environmental goals. As you can see in the upper right hand on the slide, again, you can access our website at www.ncesi.org. Now here's a fun splash screen that Angela was able to put together showing many of our members. We'd love for you to be on this slide if you are not already. And again, we would like to thank Terry Albrecht and the Waste Reduction Partners for assisting ESI staff by providing our outreach today via the GoToWebinar and also their partners, the Land of Sky Regional Council. WRP and the ESI are both part of the NC Department, North Carolina Department of Environmental Quality, which has a mission to support pollution prevention strategies. Terry's contact information is up on the screen as well. Feel free to reach out to him for more insight to the WRP program. And this opening presentation will be available as well on the ESI events page in case you need to utilize it for these contacts. And now we're very pleased to have the following presenters and panelists with us today for health, safety, and disposal of new power sources. Where in today's event, we'll cover the health, safety, and disposal of new power sources for newer technology, including lithium-ion batteries. And our first presenter today will be Lauren Lynch. I'm going to transfer the screen over. There we go. And while Lauren is setting that up, okay. Lauren is a senior research mechanical engineer within the Center of Integrated Mobility Sciences at the National Renewable Energy Laboratory, NREL, where she contributes to the research, development, and deployment of high performance, low emission, energy efficient passenger and freight vehicle technologies via data analysis, technical project management, and stakeholder engagement. As technology program manager of the Department of Energy's lithium-ion battery recycling prize, she's responsible for prize administration of the $5.5 million phased prize competition to incentive U.S. innovators to develop and demonstrate processes that, when scaled, have the potential to capture 90% of all discarded or spent lithium-ion batteries in the United States for eventual recovery of key materials for reintroduction into the United States supply chain. Now, prior to her time in NREL, Lauren enjoyed many years developing next generation after treatment technologies within Cummins Emission Solutions. Lauren, thank you so much for joining us today. I see your presentation in full mode.
Perfect.
And I will turn it over to you. Thanks again.
Great. Thanks, Don. So as Don mentioned, I'm going to kind of set the stage a little bit for what's driving some needs, especially with the supply chain materials, also requiring the health, safety, and disposal of new power sources, more specifically lithium-ion batteries in my case. So I just wanted to start off with kind of throwing a few numbers at you. The Department of Energy's Vehicle Technology Office supports early stage research to significantly reduce the cost of EV batteries while also reducing battery charge time and increasing the EV driving range. So today there are multiple sources that are projecting growth for EVs and lithium-based battery products. In addition, the Biden administration has laid out a bold agenda to address the climate crisis and build a clean and equitable energy economy that achieves carbon pollution-free electricity by 2035. So between all of this projected growth and these objectives, there's a lot of, again, different sources expecting EV battery sales to continue to increase, as well as other consumer electronic applications to continue to increase. So today I've shared a few information, or few bits of information that are supporting some of DOE's objectives that I'm going to get into later. For example, the EIA projects that US light-duty battery EV sales will reach 1.4 million by 2030, and there are actually other sources that project even higher sales growth that may be a little more recent data as well. Global EV battery sales are also expected to reach more than 20 million by 2030, which is a significant increase from 2018, which was about just 2 million. So this growth in EV sales, as well as increased demand for consumer, stationary, and industrial applications, are expected to double the demand for lithium-ion batteries by 2025 and quadruple that demand by 2030. Therefore, the demand for global production of battery materials, such as lithium, cobalt, nickel, manganese, and graphite, will continue to grow at similar rates, causing supply chain constraints, geopolitical and economic competition, and other increasing vulnerabilities that threaten to disrupt available cost, that threaten to disrupt the availability and the cost of the critical technology development. So this development requires similar support to kind of match that growth, right? So currently, lithium-ion batteries contain a substantial amount of cobalt, which is the largest material contributor to their cost. The National Renewable Energy Laboratory has forecasted the demand for EV lithium-ion batteries will surpass portable electronic lithium-ion demand by 2023. So that's, large increase of cobalt, and 60% of that cobalt global supply is mined from the Democratic Republic of Congo, where some are worried about the political and business decision-making uncertainties. In addition, cobalt is considered the highest material supply risk for EVs in the short and medium terms, leading to increased prices for lithium-ion batteries. Lithium has also been the enabling metal for achieving the high power density and low cost for lithium-ion batteries. And it takes a long time, I believe about 10 years, to develop new operation to produce large-scale amounts of lithium. So unexpected increases in the demand can also yield price spikes. Lithium is critical to long-term sustainability of EVs, but it should not be a supply risk if adequate recycling is implemented. Although some existing processes can recover lithium today, it is too expensive and new methods must be developed to make it more economically feasible. So that's some of the areas that I'm going to touch on today, and I believe my colleagues will go into more detail as well. So again, we're expecting a significant increase in demand for lithium-ion batteries, and this is in transportation as well as consumer electronics. The growth in demand for lithium-ion batteries for EVs is expected to establish EVs as the largest end user of cobalt and lithium, which in turn could potentially create a cobalt and lithium supply risk. So about 500,000 tons of battery materials are needed by 2025 to support this projected demand. Closed loop recycling can supply significant amounts of that demand material and can impact the material cost and availability. So again, reintroducing that into the supply chain will increase the availability and hopefully make it more economically feasible. NREL analysis has shown that 90% collection of material and recovery rate can potentially supply about 35% of the cathode material needs in 2023. So basically, there's a goal of recovering 90% of these materials in order to provide about 35% of that supply chain, or what's projected requirement of the supply chain materials in 2030. So in response, if you will, to these projected supply chain needs, and to mitigate potential lithium-ion battery critical material risk, the Department of Energy's Vehicle Technologies Office, also known as VTO, has established the strategic program of reducing these concerns. By September 2022, DOE hopes to decrease the cost of recycling lithium-ion batteries. They hope to recover critical materials and high-value materials and develop cost-effective methods to reintroduce recovered materials into the battery material supply stream. So there's three key aspects of this strategy, and they include the lithium battery recycling research and development of low to no cobalt cathodes, and the lithium-ion battery recycling prize. So today, I'll provide a bit more information regarding two of these three aspects, which are the battery recycling prize and the ReCell Center, where I'm joined by my colleague from Argonne National Lab, member Jeff Spangenberger, who will also address questions in the following Q&A. In addition to these objectives, though, there are multiple recent ones that DOE has put in place, including some other actions where they're supporting, such as the Federal Consortium for Advanced Batteries, and they recently released a national blueprint to guide investments in the urgent development of domestic lithium battery manufacturing value chain. So again, lots of focus on the critical material needs to support the projected growth, and more specifically, at least in my discussion, lithium-ion batteries. So first, I want to tell you a little bit about the ReCell Center, which is focused on advanced battery recycling. They develop cost-effective, flexible processes and techniques to extract as much value as possible from the current and future battery chemistries to make recycling more economic. So again, it's kind of standardizing, I guess, the processes with all these varied chemistries in order to make the process more economically feasible. The program is funded by DOE's Vehicle Technologies Office, and it involves 3 national laboratories, which are Argonne, NREL, and Oak Ridge National Laboratory, as well as 3 universities who are working alongside them. The ReCell Center's goal is to improve the economics of battery recycling and to ultimately help lower the cost of making new batteries. The center has 4 focus areas: direct cathode recycling, non-cathode material recovery, design for sustainability, and modeling and analysis in order to reach these goals. ReCell works very closely with industry to make sure that the work taking place makes sense in an industrial application and doesn't create any unknown barriers, or I guess expected barriers, right? We also help bring battery recycling experts from every corner of the country and the world to help efficiently bridge the gaps that are holding us back from realizing the best advanced battery recycling infrastructure possible. And again, Jeff from Argonne has joined us if you have any specific questions for him during Q&A. Now, the Battery Recycling Prize is a 3-phase prize with a total prize award of $5.5 million. The National Renewable Energy Laboratory, or NREL, is the prize administrator on behalf of the Department of Energy. So we're currently in phase 3 of the prize, where only winners of phase 2 were able to advance. So it's been a tiered, I guess, or funneled process where phase 1 winners were only able to advance into phase 2 and phase 2 into phase 3. The Battery Recycling Prize is designed to motivate innovators and businesses within the US to develop and demonstrate profitable businesses and technology strategies to achieve that lithium-ion battery recovery rate of 90%. So phase 1 of the prize was broken into tracks where participants focused on developing novel solutions to more specific challenges associated with collecting, sorting, storing, and transporting spent lithium-ion batteries safely and economically for eventual recycling. So we're aware that processes for these different characteristics or aspects exist today, but again, the goal is to look at those and make them a little more economically feasible. Then in phase 2, they focused on validating those track-specific concepts and then built them out into a proposal that was an actual end-to-end concept solution. So one that moves spent lithium-ion batteries from consumers to recyclers and improves the economic viability of doing so. In order to advance the track-specific concepts, teams develop partnerships in phase 2 to support all of the areas of the end-to-end concept solutions and to ensure the team has proper resources to implement an effective solution and help contribute to DOE's overall goal of recovering 90% of lithium-ion batteries. So now the primary objective for phase 3 is to conduct a demonstration, so pilot scale, if you will, that recovers a portion of the projected impact that they provided based off of their end-to-end concept solution in phase 2. So the winning teams of phase 2 must demonstrate their ability to recover lithium-ion batteries and verify the feasibility of achieving the end-to-end solutions projected impact when fully scaled. So we'll have 4 winners of phase 3, where $2 million will be distributed equally among them in cash prizes. And we're hoping these teams would then apply those funds to help support successful implementation of the end-to-end recovery process for increased recycling of lithium-ion batteries at a full-scale solution and has achieved that more economically feasible process. So we had 7 different teams advance from phase 2 into phase 3, and they each have a variety of solutions for completing the process from collection of batteries and getting them to their final stage of recycling. The teams are currently working on a pilot scale demonstration of their full process, and this does include soliciting feedback to inform their plans to fully scale. There is an upcoming opportunity that you should hear about as well as members, where the teams will be presenting on their end-to-end concept solutions and give a little more details on what they have been developing. And we encourage today's audience to take advantage of that opportunity to learn about these proposed end-to-end solutions and inform them that might help them with the business development and their plans to fully scale. Because again, we want these winners of phase 3 to implement their solutions, so it'll be fully commercialized and eventually fully scaled, and hopes to achieve that 90% or at least work toward contributing the 90% recovery rate of lithium-ion batteries in order to address some of the supply chain risks identified for the critical materials of these advanced battery solutions. So I encourage you to continue to learn more about the prize as well, because this is something that will likely, affect everyone, whether it's needing to recycle your cell phone battery or your laptop battery to coming to the end of life cycle of your electric vehicle. So you can learn more about the prize with information from today's handout. And that was included, I believe, in the chat or in the GoToWebinar support system. And I've also included a link at the bottom of this slide here, and that's on HERO-X Battery Recycling Prize. So that's everything that I had for today. And again, Jeff from Argonne National Laboratory will be supporting the Q&A to address any questions about the resale center. Thank you.
Thank you so much, Lauren. That was wonderful. And yes, we look forward into diving deeper into the recycling prize. So stay tuned for more details on that in the weeks to come. And yes, the handout is available to you in the GoToWebinar handout section, and it will be included on the ESI events page for this webinar as well. Thank you again, Lauren. And I'm now going to, whoops. Oh, me. Okay. Sorry, a little technical difficulty here. And now I'm going to change presenters. We're going to move on to our second presenter, which is Brian Polk. And Brian, I have sent the steering wheel over to you, so you should have control of it. I do see your presentation in full mode. Let me tell you a little bit something about Brian first. Brian Polk, he is the safety consultant for the North Carolina Department of Environmental Quality, Division of Waste Management. He has been such for the past 19 years. I myself have had the privilege of working with Brian, including being trained from HAZWOPER to hazardous waste sampling events over the past several years. So Brian, thank you so much for joining us today.
Oh, thank you for the opportunity, Don. I really appreciate it. And good afternoon to everyone. Hope you're doing well. And we'll go ahead and get started. So this presentation is more about the health, safety, and disposal of the new power sources, specifically the safety and risk management systems. And so we'll go ahead and get started. So our topics today, we'll start looking at the safety risk management system aspect of the organization and a few suggestions there. We'll definitely look at the fire and explosion hazards associated with lithium-ion batteries. Again, to understand the controls and safety aspect, we have to fully understand the hazard. We'll also look at some specific energy controls, and we're going to look at those from different occupancies. So we're going to look at industrial, residential, and office, and we're also going to examine the solid waste facility interests as well. And I'd love to say that everything in this presentation is my own, but it's not. So I do want to give reference to those portions that I borrowed. So we'll start off with a simple question of what is safety? And every company, organization, and person for that matter considers safety in their everyday decision making. Some would say a little bit more for others than some. So to you, think about this for a second. Ask yourself, what is safety? And we're not focusing on the result of safety, not the going home, but really what is safety? And for me, when I look at the safety and risk management system of our division and other organizations that I've had the pleasure to work with, I've always felt that safety is the distance between you and the hazard. This particular insect doesn't really care about the fly swatter until it realizes that it's in the strike path, that it's within that area where the energy from the fly swatter can be released upon it. It's really concerned then. And if we look at the picture on the right, the distance between you and the hazard, that's a pretty significant fall if you were to fall off that cliff. So again, when we talk about safety, the result of safety is going home. But safety itself, I consider it to be the distance between you and the hazard. And the greater we can make that distance, the more likely you are to go home. But what's more important about this is to ensure that if we have a job to do, if we have a task to manage, that we can recover from that task. And safety is going to help you do that, of course. So if we look at these particular pictures, what we want to see is the energy that could be released. The energy that could be released as a result of the activity that's being done. And certainly when we look at these pictures, the first two are certainly gravity is going to take control here. If the situation, an unevent situation occurs, then the energy that's released a lot of these people are going to be in the path of that energy, and that's what causes the injury itself. If we look at the picture, the third picture there, we can see that smoking, standing beside the natural gas vent, is probably not the best idea in the world, certainly, but the energy that can be released is going to go out in multiple directions. So we want to make certain that anybody standing within that area is not going to be in the path of that energy. And then lastly, sticking your foot to unjam the chipper. Again, we have to think about what makes sense to the employee as they're working. It doesn't necessarily make sense to us as we look at the result. We want to make certain that we understand what was in the employee's mind as they were doing this. But certainly, if the energy is released, there's not a lot of, the recoverability is pretty slim from that event. So being in the strike zone allows you to complete the task. So it doesn't necessarily mean that you're safe or unsafe. It just allows you to complete the task. And that's okay if sufficient controls are used to ensure recoverability. And that's the most important part right there. It's okay to work inside that strike zone as long as the controls that you've instituted can control or redirect the energy. And if that's the case, then recovering from an unplanned event is certainly highly likely. So when we talk about controls in the workplace, there's all kinds. Shield on the right, shielding of the register and the checkout area at malls and so forth. That's something that we're all used to. We've seen it for the last year. But controls. So first we have to recognize that the event can occur, and then what kind of controls are suitable to ensure recoverability. So here's a couple of thoughts to consider as we go through the rest of the presentation. I do not believe that anyone comes to work and get hurt, right? Safety and risk management should be considered a defense mechanism for unplanned events. Certain things can happen, and when they do, we need to make certain that we have something in place to control the energy so that it's absorbed or redirected in another direction, so the employees or the facility does not get hurt or damaged. Prevention is absolutely best. We as safety professionals, we love to prevent accidents, but we also realize, at least I have, that after the years I've been doing this, you cannot prevent everything. The certain things are just going to come together, and an injury is going to occur. So when it does, we need to make sure that we have something in place to make sure the employee or the facility can recover from that incident. To be sustainable, again, we must consider recoverability. If we look at what is the worst event that can happen at our facility with batteries or other types of events, how can we recover? Do we have the resources to recover from that incident? And if we don't have the resources to recover, then we probably shouldn't do it. So I like to go to work every day with an effort to prevent catastrophic events, those events that we cannot recover from, because it's wonderful to have a safety and risk management system in place that prevents all kinds of things. But when you have ever experienced a fatality or a catastrophic fire or other type of event in your workplace, you got to be able to recover from events. And again, recoverability is the most important. So let's look at the hazards associated with lithium-ion batteries and understand what energy can be released by them. So when we look at lithium, we understand that lithium is an naturally occurring element, number 3 on the periodic table. Like a lot of its fellow elements within that group, it's highly reactive, it's flammable, and generally when you see it in a lab or other type of facility, it's stored in mineral oil. We do recall, though, that lithium will not be by itself. It's in nature. It's going to be bonded with something else. So to make it stable, it's got to have some type of bond there. Otherwise, those electrons would go a little crazy. So why and where do we use it? The weight is by far one of the main reasons that it's used, because considering the weight of it and what it can do, it's very advantageous. It's heat resistant medication. Those are salts though. Lubricants, some batteries contain pure, but most contain a lithium ion. And the amount of lithium is proportional to the amp hours. Well, that's something I learned in preparing this presentation. So we look at the periodic table. We notice that it's over there on the far left. Those can be some water reactive or otherwise a little reactive substances. So just keep in mind that this is what you're dealing with lithium, even though it's a very small amount. So understanding the hazards, again, considering the size, the lithium battery stores a significant amount of energy. There's a lot that goes into that little battery as far as components, but there's a lot of capacity for that battery to absorb the energy, right? But again, it's the unexpected, the unplanned release of this energy. That's the hazard itself. So a little quote here says that there was a simple way to explain why these batteries explode. There would be a simple way to prevent it. So another thing I've learned in my life is that things are complex, and they're complex because they cannot be fully explained or understood. We might be able to understand the individual components, but when they're put all together, there's so many moving parts that it's hard to control. It's a complex situation then. So thousands of these batteries are produced. In fact, millions are in use. Compared to the volume produced to the incidents, there's not that many incidents compared to the number of batteries produced, but each one of those incidents can be pretty significant. The manufacturing process has very tight tolerances. The components of the batteries are often welded together, and small deviations can lead to failures. So if you look at your facility and you think about, what tolerances do we have in our operations? And I'll give you an example. My daughter, when I was in school, we didn't have A minuses and A pluses and all that stuff. You just got an A, and your A was from 90 to 100. So there was a lot of tolerance in there to get an A. You had a lot of capacity there to not get every single question correct on that test. But of course now with plus and minus A's, there's much smaller capacity in there. You still might get an A, but it's going to be an A minus. So a little different situation. So the main factor involving lithium ion batteries, why there's a hazard, why there's a fire, is damage to the battery housing, puncture, drop, crush it, overcharging, and that can be the charger itself, or it can be an error inside the battery. And then of course, manufacturing errors. As some of those welds or components are slightly right at the cusp of the tolerance or just beyond the tolerance, then obviously the positive and negative terminals can touch. And of course, then we have a heat, and that generates the heat. And it's the generation of heat that causes the fire and the explosion and the overall hazard associated with lithium ion batteries. So the amount of heat generated, if we want to go back to our engineering classes, we can understand that the energy balance equation can be used there. And that's important for the manufacturers, but it can also be important to understand that if for some reason you're storing a tremendous number of batteries, such as a recycling facilities or something like that. And of course, you can use that information to make sure that your fire suppression system or your response system has enough capacity to deal with that amount of heat. Factors that contribute to fire growth, obviously batteries contain a small amount of flammable solvent. There's a contributing factor. The housing is made of combustible materials. Surrounding combustible materials, depending on where these batteries are stored. And against uncontrolled spread, there's no fire suppression system. There's no early warning system. People don't have time to get up and get out before the fire or the heat and smoke are out of control. So the assessing capacity to fail. And in my thing, I'm never scared of failure. what I'm scared about is not being able to recover from the failure. And so for my failure is okay as long as I can recover from it. And you know, we may recall Thomas Edison, who said, you know, I've never made a failure. I've just found 10,000 ways it didn't work. And they didn't work. They didn't result in necessarily what the desired result was. But at the same time, he didn't burn down his entire facility. You know, somebody didn't get killed. So as long as you can recover, failure is okay. So consider your workplace. How close to the edge are you working? How close can you get? One of the things that has occurred and we've realized during this pandemic is that before the pandemic started, we were at full capacity with environmental sampling, conducting hazard assessments. You know, we were at 100%, if not more. And one of the things we started to see is a little bit of normalization of safety. Things that would not have been tolerated 6 months before the pandemic started, right at the beginning of the pandemic, when we were trying to get things wrapped up, you know, certain things were being done that got us closer and closer to that tolerance. It got us closer and closer to working on the edge. And that's both in quality and the amount of work that could be done. So we had to step back and look at our controls. Are the controls there to keep us from failing to the point that we cannot recover? So make sure that the controls that you have in your workplace, if you're working at those tight tolerances, if you're working close to production capacity, are the controls sufficient to control the energy that could be released should an unplanned event occur? So we often talk in safety about near misses. A near miss is, you know, just like the quote here says, it didn't result in injury, but it certainly could have. And near misses are what I like to say is you got close enough to the fire to feel the heat, but you just didn't get burned. And in my viewpoint, those are failures in our safety and risk management system. Those are points where the controls are not as sufficient as they should be. Something allowed you to get that close to the hazard, and that's what we have to make certain. That's why their controls are in place. So one of my favorite little cartoon strips here, the rusty lifting gear, and keep this in mind. If you are working with tools, equipment, it's going to wear, and eventually that wearing is going to contribute to a near miss, an unsafe act, and hopefully not a catastrophic event, as the picture indicates here. So this is why we do inspections. This is why we look at how the batteries are stored. This is how we look at the conditions of the batteries and the charging mechanisms, because if we use this equipment, it's going to wear, and eventually we're going to get to the point that the safety mechanisms, the capacity in there is simply not worn. It's not sufficient anymore. So how do we control the energy? We're always trying to control the energy. We know that we're working in a place where there's a stored up, you know, kinetic energy, if you want to use that term. How do we control the energy so that it is not released unexpectedly? And if it is released unexpectedly, that it's redirected or put into an area where they can be contained. So controlling energy. Batteries store energy, we know that. These are things that we know as we look at our production facility, as we look at our operating facility. The unexpected release of energy, the heat, failure is an option. All the controls that we have may not work. And again, controls must be used to ensure recoverability. So we're going to look at controlling energy. As we know, some of these batteries are considered hazardous, and as they are, universal waste rules apply. And those rules are, again, they're controls. If you adhere to the rules as they're written, then those are controls that we can use to redirect or prevent the unexpected release of energy. But they're also dependent on the location too. What you have in an office versus an industrial and especially a solid waste facility, the controls have to differ depending on the facility. And again, the more people you have exposed, the slower you want that fire to spread, if at all. So certainly in the residential and office occupancies, charge batteries according to how they're instructed. And this can be a big issue if you have international type of facilities. Maybe they're bringing in circuitry that's intended for different hertz. All right, that's something to consider. Store batteries in well ventilated areas, direct from sunlight and heat sources. Again, if we add heat to the batteries, the housing itself is going to fail, and that could contribute to the fire. I've seen a lot of batteries, and we'll see them in a minute here, that are stored on top of totes and everything else, and that could contribute to the damage, as well as stacking heavy object on top of the batteries. And of course, isolating the lithium ions from other types. So if there's a fire that can be easily suppressed with one type of battery, lead acid, then that heat doesn't generate over to the lithium batteries, where the energy from those batteries can be much more intense. Again, packing the batteries and having everything together, this is just more load for the fire. It doesn't take a lot of effort here to push the fire into areas that are not as controlled. In a previous life, right during the end of college, I was hired by a pharmaceutical company to go inspect safety equipment throughout their facility. And we had little wands that we had to walk around with, and that's how we recorded the information from barcodes and what we observed throughout the facility. Those wands operated on 9-volt batteries, and we were always told to carry at least 2 extra batteries. These are certainly not lithium-ion batteries, and to always tape the terminals to the 9-volt batteries, because if they ever shorted out, using change or keys in your pocket, it would burn a hole in your pants for certain. And I learned that the hard way a couple of times. Fortunately, I was able to recover. But again, in the right side, obviously the battery here is damaged, it's bulging, it's heating up. And those are some of the things that you want to look for when batteries are being stored for an excessive period of time, or when your staff is using wands and other devices that just don't seem right. They're not operating right. So industrial facilities, some of the things to look at, again, there's all types of lithium-ion batteries that are being used in all kinds of pieces of equipment all over industrial facilities. As a part of this, as a part of that, occasional inspections, especially after they've been dropped or damaged, is needed to ensure capacity to fail, to ensure the integrity of the container is still intact. Again, one of the big things is, where do you purchase the batteries from? There's not a tremendous number of manufacturers for lithium batteries, because the raw source is so limited. But at the same time, how they're put together and manufactured in the different devices, from forklifts to wands to vehicles now, that does differ. So make sure that the quality is sufficient for your manufacturing activities. And especially if they come in raw products, so make sure the batteries are inspected, especially those that lack adequate protective packaging. Again, use and store these. When we talk about more heavy industrial type batteries that can store a lot more energy, we want to make certain that they're inspected, integrity and everything is sufficient for them. And some would say store in metal containers. I think that's going to differ depending on the manufacturer, where you get them and how you're using the battery. Sometimes storage in metal containers is not even an option. What it does is try to protect it from a fire that may be headed toward those batteries. Other fire control, make sure that your suppression system is adequate for the what you're storing in there. We've seen a number of times where the sprinkler system for a particular facility was designed for one application, but now the building is being used for an entirely different purpose. We have to make sure we size the suppression system according to the hazard. And of course, that also applies to vehicles as well. Most of you are aware that larger construction vehicles have their own suppression system in them. in many shredders and other types of fixed equipment that may be in your facility may have a suppression system on it as well. Again, making sure that the suppression system is sufficient to control the heat that may be generated. Fire extinguishers, by far the biggest thing is ABC fire extinguishers, making sure that they are sized and deployed accordingly. BC fire extinguishers are good, but I would still stick with the ABC. Class D are for flammable metals or combustible metals. And I wouldn't go out and purchase just a Class D unless you have a particular laboratory or something like that. They're under much lower pressure, and the amount of combustibles around them is going to far outweigh the benefits of the Class D. And there is a new fire extinguisher that's being tested, if not already deployed across the seas, vermiculite depression. This is not available, to my knowledge, here in the U.S. yet, but something else to look at. And fire blankets covering the fire. I've seen this a lot in laboratories where they're using a small amount of sodium or other type of flammable liquid, metal, I mean. And so that would be an option as well. And we could jump over to the solid waste management facilities, specifically transfer stations. When prevention fails, that means the battery was damaged at some point and now there's a fire. Solid waste facilities really already have plans in place to manage fires, and fires involving lithium batteries do not require significant changes because more than likely the fire concern is the amount of combustible, the volume of combustibles surrounding the fire itself. And what we want to try to do is isolate that fire and isolate the amount of combustible material around it. We do have to think about exhaust fans, especially if it's an enclosed transfer station. Is that extra ventilation going to add oxygen fuel to the fire, or is it going to exhaust the smoke that is there? Early detection is by far the best, and that's why we have fire alarm systems. That's why we have detectors, thermal imaging cameras, like you see on the right, things that are set to go off to detect it, so people in the facility have more time to get up and get out. There are also some videos that I'll show you in just a minute about a facility up in Maine that now has water cannon and deluge systems that can be used to extinguish fires. We'll come back to that in just a second. Considering all the moving parts, things can be very complex, as we're aware. When it comes to suppression systems and responses and how to store lithium-ion batteries, or anything for that matter, there's a lot of moving parts, and that kind of adds to the complexity of the situation. So evaluate where unexpected releases of energy could occur. Think about your facility and how could that energy be released, and where is it going to be released? How is it going to be released? Keep track of your near misses. Again, these are points where the controls are beginning to fail. And again, failure is an option if controls are in place to ensure recoverability. And again, I try to work every day to keep catastrophic incidents from occurring. It's wonderful to prevent sprained ankles and minor injuries like that. But if we don't prevent the catastrophic injuries, then that doesn't look so good. So again, references. I'm a big follower of Dr. Todd Conklin. You can watch a lot of YouTubes and stuff with him. A couple other videos there to watch with regards to managing lithium batteries. And NFPA 82, this full disclosure, I chair that committee and have so for the last 10 years. There's a lot of information there available on the storage, and especially for waste handling equipment. Before we finish, just a couple little things here. I don't know if you've ever been asked this question, but why do cars have brakes? Think about that for a second. And cars have brakes so we can drive faster. You know, if the car didn't have brakes and you wanted to use it, you wouldn't drive very fast, right? But if you've ever had a bicycle where the brakes failed, I think you kind of understand where I'm coming from there. And again, lastly, one big thing I've learned in the last couple of years is when we talk about incident review and incident investigation, I'm convinced now that no one comes to work to get hurt. And when we investigate these incidents, we have to look at the controls. And usually what I found is that the controls are either absent or they were simply not sufficient to hold or redirect the energy being released. So Don, that's it. I appreciate the opportunity. Let me know if you have any questions.
Yeah, thank you, Brian. And again, if you want us to post this presentation on our ESI events page, just feel free to send it my way. But
Okay.
thank you so much, and we look forward to having you back on the panel and during the Q&A. I'm going to go ahead and transition to that, and let's see, to Jacob Folks. I'm sending you the controls right now. And while Jacob, just confirm if you get that, and you can take over. See it coming up now. Then slideshow presentation. And while there we go, let me tell you a little bit about Jacob. Jacob is the site environmental engineer for Freightliner Custom Chassis, in which he has been in the position for 2 years now. Jacob has a bachelor's in environmental engineering from Clemson University and is in the process I'm sorry, I just got to show you. He's in the process of receiving a master's occupational safety and health with a concentration in environmental management. And let me, I had Lee Barrett's bio up here, but SharePoint has signed me out. So what I will do is let me go ahead and let you start on that, and then I can share Lee's bio towards the end, since Lee's going to be joining us for the panelist session as well, correct?
Yes, I'll be joining as well.
Okay, great. And Jacob, it's all yours.
Are you able to hear me now?
Yes, I am. Thanks.
Okay, good deal. Well, good afternoon, everyone. Thank you, Lauren and Brian, for what you've shared so far. What I'm going to talk about here for us here at FCCC is very specific to what we do. So we'll go ahead and get started. As you can see there in the background, that's the Julie, just to give a shout out to the best thing made in North Carolina. Had to put that on there as well. So the first thing I want to start out with, just a little background on Freightliner, what we do here. So we run 3 production lines here at the facility. So our line 1 is our school bus line. So that's where we're running our electric vehicles, our electric school buses. We have recreational vehicles on our line 2, and then line 3 is our walk-in van line, and we're starting to run electric vehicles on that line as well. So walk-in vans would be FedEx, UPS, vehicles like that. And what we build here specifically are the chassis. So if you see this picture here, the body has been taken away and you can just see the underlying chassis. So that's what we build here specifically. So just a little background, for every employee that comes in on site, they are now being trained, high voltage trained, so they can be prepared for what they might expect regardless of what production area that they are sent to. So whether it be materials where they could be handling these lithium-ion batteries, or at line 1 shop floor employees where they will be actually installing these batteries or messing with the EV units, running lines, things like that, along the production line as well as line 3. So this is just how we rank those. So employees without training, what they're allowed to do around our high voltage vehicles, so on and so forth. The high voltage 1 training is for all of our employees that come in on site. So they have the ability to drive these chassis off the end of the lines. As you go up, as you do more things, whether that be our offline work, obviously we require more training. And so those are conducted by our electric vehicle manager. His name's John, and he does those trainings for us here. So just kind of how the system works, what the battery does for us in our chassis. The on and off switch is located in the battery itself. So here's how it's all connected. You have your drive motor, which goes to your drive inverter, and your battery is constantly running through those, checking signals, checking connections, making sure that everything is running as it's supposed to throughout the vehicle itself. So how do we receive our batteries? That's one of the biggest issues that we had coming into electric vehicles. So you can see down in this lower left-hand corner of the pictures there, we have these large wooden boxes. So these batteries, when they come in, it's 2 batteries stacked together, and they weigh right at 2,600 pounds a piece. So definitely not a light battery at all. So they were coming in these wooden crates. We were having to figure out a way to get these wooden crates, make it a sustainable process. So what we did from there, originally we were breaking down these boxes, throwing it away in our recycling wood containers, disposing of it that way, and that just wasn't practical for us. We had so many batteries coming in that we needed to find a better way to bring these batteries in from our distributor and to be able to handle them more safely. So you'll see the racks, the nestable racks there. These are now returnable racks. So from a sustainability aspect, we're able to send those racks back to get them refilled essentially with another battery. That way they can safely come in, they're safely transported, and they're easy to move around the facility once they arrive. Also mentioned there, the batteries come in upside down. So as our production line runs down, once we get to battery installed, the chassis itself is actually upside down. So we're installing these batteries in an upside down chassis. After that process, the chassis is then rolled over and then continues down the production line. We do that for several reasons. It's a lot easier to run some of the cabling and things when the chassis is upside down before it's rolled over. So it's just easier to talk to our distributor to send those batteries in upside down. That way we weren't having to flip them ourselves, and it was a lot safer for our employees to handle. They can use the hoist, which we'll talk about here. We can use the hoist located on line 1 and our line 3 with an H-bar that helps to stabilize the battery as it's being installed. They're able to drop the battery directly down inside the chassis, run their harnesses, run their bolts to make sure it's in there sturdy before we actually flip that chassis over. We also developed a cart and dolly system. That way our materials group could load the chassis or the chassis batteries, that high voltage battery, onto a cart and dolly and then carry it over to our production lines. They're able to slide it right into the location where it needs to be. That way our employees are able to hook up very quickly to this battery, get it raised up into the air and into the chassis installed, ready to go in a significant takt time. That way we're keeping our takt time low, not causing downtime, and we're able to continue producing that chassis as it goes down throughout the facility. So here's just a phase diagram of what happens here with our chassis builds. So here at the main plant, just our main center here, we're doing our chassis build down the line. So from chassis build, that would be where our rails are put together. We're at battery install. From battery install, we go to install motors and trans, then install underhood components, and then we move our chassis to our offline area. At this point, the batteries, the chassis have not been commissioned, so they're being hauled off the end of the line and taken around to our offline area. From there, in our EV offline section of offline, they're going to do the high voltage wiring, making sure it's complete, everything's where it needs to go before they actually commission the vehicle. From that, they're going to power up and test the vehicle, again, making sure all those connections are good, making sure everything is safe before the product continues down to our roll test. And then once we get to roll test, we're going to run the ABS system. We're going to dyno the chassis, so we're going to run it up to speed, make sure we're heating up the batteries, heating up the fluids, things like that inside. Just making sure we're good there. We're going to check for leaks, things like that. After we run it off of our dyno, we then ship it to Thomas Built Bus in North Carolina, where they are going to put the body on the chassis. So here's an an AutoCAD image of what the chassis actually looks like with the battery installed. If you could see my mouse as it's moving over the battery or moving over the chassis, this front part here under the cowl, this would be our cowl, this is where that battery is installed. So it's a very detailed process. Our employees are running these lines, making sure everything is connected. And so once it gets to our EV offline area, this is where they're really going to fine tune, dive in deep to all the aspects of our chassis build, making sure everything's connected, everything's where it needs to go, and then they will then commission the vehicle for it to be sent out through the process. So now I want to kind of talk about our emergency response. So how we plan if we have an issue, how we would deal with that situation. So if we're having a leak, the electrolyte, as Brian spoke about, is very corrosive and irritating to the skin. There's also some ignitable components to it as well. So we just have to make sure that our employees are safe, make sure they're taken care of. So the first prototype we have was the lower picture there. That's up at our EVC, where we do our test and development operations here. The battery can fit down snugly inside that container there. That lid can be closed until it can be properly taken care of. So far, if we have an issue, it's been a minor issue, but we send those batteries back to Proterra. And then the C container that you see up above, the orange container with the roll-up door, it is used for our production. So obviously, as we run production, we continue to build chassis, we continue to have more opportunities for battery failure. So we needed a bigger place for these batteries to be stored. So Lee, who you'll be able to talk to here in a little bit in the panel questionnaire, actually was able to get this C container, modify it to be able to put the roll-up door in it. So when this roll-up door, if we have a battery that's malfunctioning or has a leak, things like that, we're able to put it inside this C container until it can be properly controlled and taken care of and taken back to Proterra. So same thing here, if we have a fire, this is what we expect our employees to follow this process. So notifying our battery specialist. We have 3 battery specialists here on site. Most of them are in upper management, but if we have a battery issue, if they malfunction, whatever it may be, they should be notified. That way they can get out there, get it taken care of, and get it moved to a safe location. Same with smoking. If it's observed escaping the battery pack, the team leader and the supervisor need to be notified, as well as the battery specialist. And then again with heat, that will be the process as well, notifying them, letting them know, hey, we have a battery that's malfunctioning, there's something wrong with the battery, it's smoking, there's heat coming from it. That way we can get out there, get it taken care of, and move forward. So with that communication, we have to communicate with our local law enforcement, local fire department, local police station to let them know what we have going on here on site. So we have annual meetings with the local fire department as things change, as things grow, as we continue to develop these production areas, especially as we move into walk-in vans. We need to make sure that they're on the same page that we are. So if we have an issue, this is how we respond. What do you expect from us here at FCCC to be able to help you get to what you need to get to? Same thing with our local law enforcement. So when we have police officers come in, they need to know the site layout. Same with our fire department. They need to know where these batteries are going to be stored, how they're stored, and what is the safest way to deal with these batteries to make it safe for them to come on site, to make it safe that our employees are still going to be safe as they're moving away from these areas, whether we're evacuating or whatever the situation may be. And then from those communications, obviously we have to create contingency plans and continue our emergency response procedures. Again, just making them aware of what we have going on, what they should expect, and what we should expect from this process. I know that was really short. I really just wanted to dive in deep on what we actually do here in specifics. This is my contact information, as well as Lee's, who will be in the panel questionnaire. So if you don't need anything from us, that's all I've got, and I appreciate the time.
Oh, Jacob, that was wonderful. Thank you so much. 3 wonderful presentations today. And let me go ahead during this transition and introduce your colleague, Lee Barrett. I'm so sorry I got signed off from the other computer, but Lee has been with Freightliner Custom Chassis Corporation for 22 years as of June 28th. His career there began in production as he worked on the production floor. And then Lee continued his education wherein he received his AS in computer programming from Greenville Tech and eventually received his BS in IT security from Limestone College in 2010. After graduating, he moved into a facilities environmental tech role, then into a manufacturing engineer position, and is now currently the facilities engineer for the Gaffney, South Carolina location. So Lee, thank you so much for joining us along with Jacob, Brian, Lauren. It's been wonderful. And I'm going to transition over to Scott Pfister, who will give Jeff Spainberger's bio as we enter the question answer session for our panelists. Everyone, don't forget to, you can raise your hand to pose a question, or you can use the chat box to relay a question as well for everyone. Scott, Caleb, it's yours.
All right. Just to start off here, I have a question from Darren for Brian. Is there a big difference between lithium-ion batteries and lithium batteries when it comes to how to control the fires that they produce?
That discussion is probably a little bit more detailed. Yes, there is a difference, but what we probably want to focus on mostly is the surrounding combustible material and determining if the capacity of the suppression system or the firewalls and so forth are sufficient to control all of that before we start talking about the specific extinguishing methods for the difference between those two batteries.
All right, and also noting too that there are many, it's not just one lithium ion chemistry, there are many lithium ion chemistries. Is that true, Brian? And how do you take into account the different chemistries for different fire risks?
Let's see, we could take a long time and answer a question like that. But again, I think it goes back to what are you trying to protect? Why are we, my fire prevention engineering days is, what are we trying to protect? And certainly the chemistries of the batteries play a significant role in the amount of heat and how fast the fire can spread. So again, every situation is going to be a little bit different. So I would hesitate to give a generic answer to such a very broad question, or more specific question.
Gotcha. Great. Thank you. And before we jump into any more questions here, I just want to introduce Jeff Spangenberger. Jeff is a materials recycling R&D program lead in the Applied Materials Division at Argonne National Laboratory. His group works to solve material separation, recovery, and recycling challenges, resulting in cost-effective, environmentally sustainable processes that are then transferable to industry. His current focus is on lithium-ion battery recycling, and he is the director of the Resell Center, an advanced battery recycling program funded by the Vehicle Technologies Office of the Department of Energy to evaluate and advance the cost-effective and sustainable recycling of end-of-life batteries. Welcome, Jeff, to the panel here for Q&A. And I thought that we here at Deeks had a really long divisional title, but I think you guys beat us by a few syllables there in words. So, so I'll kick the next question to you, Jeff, since you're joining us here and have definitely some expertise. So for those, and it's difficult sometimes to assume on the attendees here. So for those who are closer to the beginning of their journey on this topic, what are the particular important reasons why we should recycle lithium-ion batteries?
All right, yeah, there's my video. Hey, thanks. There's a lot of reasons why we want to recycle batteries right now. The one that I talk most about is actually a national security issue. We don't make a lot of the materials that we use in our batteries today. We don't produce them in the United States. We actually don't manufacture a lot of the materials that go into the batteries. We're good at assembling them, however. So in recycling, that provides us the opportunity to create our own supply chain and help supplement the supply chain. So there's a national security component to that. Another one, though, that I think a lot about, and especially as I listen to the other presenters, battery recycling, if we can get, actually, it's tying it all together. We have the battery recycling prize that collects the batteries and brings them to the recyclers. The recyclers then can recycle them. And if we don't do all these things, we don't handle them safely, then they go down the wrong path. And that's what a lot of people don't know. I think it's important that the education piece get out there, because if we don't recycle these batteries correctly, they end up going to the landfills, the municipal recycling facilities, and that's where they can start to cause problems, because they're not handling those materials. They're not meant to handle those materials, and there's safety issues. So so there's a lot of different reasons that we should be recycling.
Great, and I know Lauren obviously laid out the path for the demand side of those things as well. So that's great that you definitely added on to that. And just a quick follow-up. So I know that in your bio here you've mentioned cost-effective is something really important. So why is that? Why should that be a high priority when developing these infrastructures for recycling batteries?
Yeah, thanks, Scott. The economics are very important. If I like to give the example, at least in the Chicago area, if you were to take a chunk of metal, whatever it is, some sort of scrap metal, you put it out at your curb, it's gone in like 30 minutes because there's a value to that material. If you put another challenging area as plastics, you put, I don't know, a plastic toy out at your curb, it'll sit there until the truck comes and picks it up. A lot of times today, if we put our batteries out at the curb, not many people really, you don't do this, but if you were to do that, because there's not that much economic incentive, they'll sit there until it goes to landfill. So the economics are necessary to drive and provide a need or a want to recycle these materials, and so they actually do take place. So the economics are really critical to keep everything, well, sustainable.
Great, thank you. Lauren, I definitely just wanted to give you an opportunity. Is there anything that you'd like to add to what Jeff was saying there?
No, nothing additional to add. I think you did a great job of highlighting those key points. Just that there's a lot of opportunity, right, in this area right now. There's a lot of focus as well coming from the Department of Energy and other organizations to help address these infrastructure needs and develop them to avoid some of the potential problems. There's a lot of grant funding that will be provided as well to help American entrepreneurs and businesses. So I think it's something, to be mindful of and stay aware of. And also as consumers, right, we're using a lot more lithium-ion batteries ourselves. And there was a time where everyone knows don't throw away lead acid batteries. So I feel like we're going to develop the same needs and kind of opportunities for lithium-ion batteries as well.
Great, thanks. And while you kind of have the podium there, is there anything that can be taken from the history of lead acid batteries, the lead acid battery recycling infrastructure? And that's been a very successful what is it, 95+% of lead acid batteries, at least in the US anyway, are recycled. So what can we take away, or what has been taken away from that and
Yeah,
linked to lithium ion?
I think there are a few teams actually are using some of the existing infrastructure for lead acid battery platforms. So that would be some of the collection strategies, right? There are different companies that exist that go out and collect the batteries. The safe transportation is actually one of the more unique areas that are very different compared to lead acid batteries because of the hazardous materials. So just one area, I guess, that's requiring new development, and that isn't as a baseline from lead acid, as well as just some of the means, I guess, to recycle. So the baseline infrastructure and logistics process, I believe, is there, as well as maybe some collection strategies of the consumer electronics, right? So maybe providing boxes at or collection sites at big box stores, like going to Home Depot and being able to drop in your old, like weed whacker battery, right? That's died. You can just drop it in the box and then it'll be collected and taken off for safe recycling and disposal rather than throwing it away into your recycling bin or waste basket that's going to be picked up on the curb. So I guess just some of those existing areas, but the main differences are just addressing the hazardous potential of the lithium ion batteries and some of what, Brian and others touch base on today.
Yeah, leading off of potential problems or issues, we have a question here for Lee. What potential procedures do y'all have in place at Freightliner to prevent or deal with problems that arise from lithium ion batteries?
I'm going to have to say that I think training is a major part of that. As Jacob alluded to, the high voltage training is very thorough. There's certain things you can and can't do. There's even areas if you're not trained enough that you're not even allowed in that area. So there is some, access control to make sure people, they know what they're putting their hands on. So as far as employee exposure, that's kind of what we're using for that. Jacob mentioned also about our commissioning process. That is it sounds quick, but it's actually hours-long process to commission a vehicle. Arc flash equipment is done to make sure that employee is protected. Like I said, they have received the correct amount of training. They check insulation. They check on the high voltage cabling to make sure that it meets the standards that Proterra has set out. So as far as the employees and the commissioning is concerned, that's all a major part of the truck, right? I mean, obviously battery transport is a big thing. That's why we wanted to get away from the wooden crates, because that is a combustible material that doesn't need to be surrounding a giant battery. Not to mention the fact of the recycling capabilities for the returnable racks, the gains that we get from that. So like I said, that's all kind of revolved around the employee safety. As far as handling and facility infrastructure upgrades, we've had to make a significant amount of upgrades to some of our the facility with regards to lifting fixtures and whatnot, because I mean the batteries themselves, like I said, we added about 4,000 pounds to a truck at rollover, and so we had to make some upgrades to hoist and structure steel and the likes to make sure that we could accommodate that, to make sure that we were, rolling over these trucks safely or offloading them from the line safely. And we've also, Jacob showed the pictures of the different types of containers we have outside. And those were, just kind of, as far as the size of batteries we use, it's still fairly new. I mean, cars have been, running EVs for a little while, but their batteries are smaller compared to what we're putting inside buses and our sister plants up in Portland doing the EV Cascadias, the big trucks. But those batteries are 10 foot by 3 foot, and there's 2 of them. So there's a lot of potential there, obviously. So what we've kind of done just as a company is practice share, not with just the plants that have these batteries, but also our global risk insurance, any kind of subject matter experts on EV from our sister plants with Mercedes-Benz, because Germany's done a lot of research on the lithium ions and how all that works also. And there's been some policies obviously developed as we kind of go down this path that's fairly new to all of us with regards to the class vehicles that we make. That we practice share. We kind of figure out how Mercedes has done some things, but we try to apply it to our processes. The kind of how we should store these particular batteries, what specs should we be following, as far as temperature wise, access wise. Even as far as we took into account how close our nearest fire department is. We're in a great situation because the fire department actually sits on leases a part of our land that our plant actually sits on. So, a quick walk through the woods, I could throw a rock and hit a fire truck. So, those things are great about our location. Like I said, we've implemented the different containers to kind of house that, and they're away from the plant. Part of the spec was to have a 50-foot clearance around that area, because if we do have an event that a battery catches fire, that it needs to be away from everything. And early, when we were first going down this pathway, they just have to burn out. You're just trying to protect the area around them to make sure nothing else is affected by that. Same thing with the truck. If we actually have a battery that's installed inside of a chassis, it's not that we can pull it out of the chassis real quick. We have to get that chassis to a location to where it can sit and do its thing until we can have the right people involved to take care of that issue. We have, of course, been talking to Proterra. Proterra is out of Greenville, South Carolina, and then they also have their batteries are manufactured in California, Burlingame, California. Obviously, close relationship with them because they've been doing their drivetrains and their batteries for a couple of years now. So there's definitely been some, close relationships with us and them. We've had site visits to Proterra in Greenville where they have, way more batteries on site than we do. Just to kind of pick their brain, talking about, have they talked to their local fire department? What did they kind of run into whenever they kind of came into the scene on these electric batteries? What kind of obstacles did they run into, or just kind of some practice share with them? Because they were the experts on the EV at that point, because like I said, we're using part of their powertrain for our buses. So, and as everything kind of progresses, EV is the way to go. And I like what Jeff brought up, kind of, why, as far as why is recycling important? And we all know how gas is, or any kind of petroleum products. If we start importing a lot, then it affects gas prices. And we are in a spot that if we don't, get our own raw materials and we're dependent on other countries for these raw materials, then that can definitely have an impact. And I like the statement that you made, that if we are able to recycle some of these batteries to help offset some of that supply, I think that will wind up helping us as a long run, because EVs, I think, here to stay. I know that the technology will change. I know it'll get better. And I think, the processes to deal with these are going to have to kind of get better also. So I'm curious to see how EV is going to kind of transition and grow. I think it's going to be very interesting.
Great, thank you so much. Just an announcement here. We've got a few more minutes, maybe for one or two more questions. And while folks are thinking about that and they're typing them in for us, Jeff, can you just talk kind of briefly about if a lithium-ion battery or a cell is damaged, say from fire or it's pillowing, how are those handled or recycled differently than one that is not?
That's a good question. There are different, so they're considered DDR. I don't know if I can remember all of those. Damaged, recalled, and I forget the other R. But essentially, they need to be packaged differently because there are more hazards associated with them. It's fairly expensive to ship. But ultimately, at the end of the day, they're recycled in the same manners as they would otherwise. The current technologies today, which are pyro-based using heat or hydro-based using acids, still will basically treat those batteries the same at the end of the day.
Great, perfect, thank you. And not to call it a lightning round, but maybe some brief thoughts on from everyone, and maybe we'll start with Brian first here. So how can organizations begin to think about health, safety, and disposal on the front end when they're making purchasing decisions?
That's certainly when safety starts, is at procurement. What hazards are you bringing into your facility based on the products that you're purchasing? So exploring your vendors, seeing what precautions they have, are dictating what type of packaging or how things are supposed to be arrived at your facility and what specifications do they need. And I was really impressed with the Freightliner saying that, we want these upside down because it eliminates hazards. It facilitates the installation of the batteries. So yeah, those are some steps, and I believe they start right at procurement, right at the time that the hazard comes in the door.
Perfect. Yeah, thank you. And Lauren, did you have anything to add?
Double muted, sorry. Just more echoing Brian, self-awareness, education, and educating others.
Great, perfect. And since Brian gave you guys a shout out there, Jacob or Lee, did you have anything to add?
No, I don't think so. I do think it is very important that we consider these things before they're brought in on site. I know it took a lot of planning from our purchasing end, trying to figure out not only how to deal with the batteries, but there's a different line of fluids that we have to have with these electric vehicles. So how do we deal with the fluids? How do we recycle those? Can they be mixed with some of our other recyclables? So I think it's extremely important to make sure you're looking at those safety factors before the process actually starts.
And I think bringing in our the first responders, bringing them in early so that they know what they're kind of going to walk into if there is a catastrophic event. They know what they're dealing with. They know where everything's going to be and kind of how to address, so that we're not, injuring any of those that are there to help us in time of need.
Great. And we did actually just have a question come in here right at the end, and I noticed that we're getting right on the end of the hour here. So I wanted to check in just real quick with Don first.
Go ahead, Scott.
We still had time. Okay, great.
Sure.
So the question actually, it might need a little more research, but I don't know, Don, if you could answer, or if we have any of our other DEQ staff, Brian, might not have the exact answer, but I'll give it a whirl here and we might need to follow up. But would you share how environmental permitting is needed in North Carolina for large battery storage sites being built that work in conjunction with utility scale solar farms? So question, about big microgrid systems and battery storage.
I think.
Go ahead. Oh no, I was going to say I'm unfamiliar with that, so please go ahead and take it.
Yeah, I would say from the aspect of DEQ, specifically the Division of Waste Management, is it a waste, or are they being accumulated for recycling? That would be our interest in for the regulations that we have. Is the battery considered a waste? And until it's considered a waste, then that would probably be more than likely a local fire marshal permitting type issue for to be determined by them. But once it's a waste, obviously universal waste rules would apply as well.
And one of the benefits here within our Division of Environmental Assistance and Customer Service is that we have the state split up into 7 different regions, and we have permitting coordinators in each region, which if we can get to this person who asked this after the fact, if you'd like to get in contact with one of your local permitting coordinators, they'll be able to definitely assist you. And as was mentioned, there might be some local jurisdictional rules and regs that might have to be followed. So, all right. I believe with that, that's the last question here. I know I could talk with our presenters for the rest of the day here, but I'm not in charge. So Don, we'll hand it back to you.
No, thank you all. I'd like to thank all of our presenters and panelists for your time, effort, and expertise regarding today's webinar. Fantastic. Thank all of our attendees for being with us here today. Check out our website, www.ncsi.org, for the webinar recording link and materials when they become available. And there will be a survey to get your feedback when you exit. Please take a few minutes to complete it, as this helps us improve the ESI and to make sure that we are offering information on topics in which you are interested. Thank you all again, and have a great day, and stay safe and good health to you all.